So again, I would start by graphing y equals x minus 3 first. It's a straight line. And it has a slope of 1 and a y-intercept. So 0, negative 3, over 1, up 1, over 1, up 1. I would keep doing this until I found my x-intercept is at 3, 0. Here is the graph of y equals x minus 3. And right beside it, I would start with my asymptotes. Where's your non-permissible value going to be in y equals 1 over x minus 3? X can't equal 3 is our non-permissible value. That matches up with our x-intercept over here. So at x equals 3, I draw my vertical asymptote, and all of ours are going to have that horizontal asymptote at y equals 0. What's going to happen to 0, negative 3? Becomes 0, 1 over negative 3. When I find other points, for sure, what's this point? When x is 4, y would be 1. So in my green graph, I'd have 1 over 1, which is still 4, 1. Question?
How many points do you need on an asymptote graph?
Technically 1 in each section. The other one that's, I mean, if you can find the one where it's 1 or negative 1, for example, like, can you see that I can have on the blue graph here, when x is 2, y is negative 1. So 2, negative 1 will also be a point on this one. Technically 1 to the left of the asymptote and 1 to the right of the asymptote is enough. I probably recommend doing 2 just to really get an idea. And it's not hard. Like I have 4, 1. How hard would it be for me to find, oh, I have 5, 2, so I have 5, 1 over 2. Draw it towards the asymptotes. Okay? Whew. In grade 12, they're really picky about asymptotes. I might lose a half mark here because it touched it. I got a little bit lazy. You can also lose a half mark if you get close to it and then sway away at the end. They're like, it's supposed to get closer and closer and closer, so this part would be bad. Better erase it so you don't copy it down. Okay? But if we're lazy, like, I think I would get away with this. But if I, went through it and then tried to come back, they for sure take off half a mark for sloppiness in grade 12. Okay. Next it says in part B, what is the domain and range?
How do you get point to 5.5, 2?
5, 2?
Yes.
If x is 5,
Right.
5 minus 3,
Right.
2. So I can plug it into my equation to find any values I want. Like pick another value number for x.
8.
8. So I want to know 8 comma something. I can plug in 8 for x. And I would get what for y? 5. Perfect. 8 comma 5. Which means on this graph, I'd have 8 comma 1 over 5. Which you can see you see that in the equation too, right? What happens if you plug in 8 for x? I get 1 over 5. So we can see it in the equation, and we can see it from graph to graph. Sometimes you have the equations, sometimes they'll just give you the graph and ask you to say what would the reciprocal graph look like if this then you need to know that you can change the y values to 1 over y. But if you have the equation, you can find the y value by just plugging in x as well.
How in any way can we use this graph?
How in any way can we use, there's lots of things in physics and stuff that have reciprocal relationships. So sometimes you have, like if you have one, what it's saying is, if you want to find any kind of reciprocal relationship, we now can graph anything. Okay, so like in trigonometry, you've learned sine, cosine, and tangent. Next year, you learn the reciprocal graphs, cosecant, secant, and cotangent. How are they related? They're related this way. Okay, so there's lots of real-life relationships between an equation and its reciprocal. And so what we're learning is how those graphs relate to each other, so we can do it with any graph. Yes?
Can you get the stuff in the green graph again?
Two ways you can get the stuff on the green graph. First of all, the asymptotes, you will always have y equals 0 asymptote. And the vertical asymptote happens at the non-permissible value. So my non-permissible value for this equation, x can't equal 3 because then you would divide by 3. That becomes your vertical asymptote. Then I can just plug in x values, like what happens when I plug in 0? I get 1 over negative 3. That's how I could find the point, right? I can just actually plug in values, or I can take my original point from this, the bottom graph, and just change my y value to 1 over it. So I had 5 comma 2, now I have 5 comma 1 over 2. I had 2 negative 1, now I have 2 comma 1 over negative 1, which happens to still be negative 1. Okay? Yes?
Are we gonna do that with x squared?
We're going to do that with x squared graphs as well.
Yeah.
So grade 11, we do it with lines and x squared graphs. Grade 12, you do it with every single graph. Because in grade 12, you learn sine graphs, cosine graphs, tangent graphs, log graphs, x cubed graphs, x4 graphs,
All the back graphs.
all the bad graphs. So we'll do this same topic again in grade 12, but you can put any graph on the bottom. And the idea is exactly the same. Okay? This question also asks us for domain and range of the green one. The easiest way to write the domain is just to say what it can't equal. It can equal everything else. Sometimes this is enough. Sometimes you'll see this written afterwards, that x can equal everything else, just x can't equal 3. What about the y values? Well, there's only one y value that it can't equal. Y can't equal 0. Y can equal everything else. Question?
Why, what does the euro sign mean?
The euro sign? The euro sign means,
It's not currency. Using euro.
and it's an E because
It's element.
is an element of. X belongs to all the real numbers.
Oh, so if you
Because sometimes you can only belong to the integers. Right? Some things like shoe sizes only happen in every half. Or if you're European, they don't happen, you can't buy a 37 and a half European size shoe. They just have 37, 38, 39, 40. Right? No? They have 36 and a half? No, not the European ones that come to Canada. We never get them. Do you have 36 and a half in Germany? Unbelievable. We can't get 3/4, right? No.
Is there a thing that's 3/4 shoes?
No? Well, I'm sure there's like somewhere you can get platforms that are like 9 3/4 size.
R,
So,
X is equal to R, is that wrong?
Hmm?
You said X equal to R, is that wrong?
If you just said that, that would be wrong because there's one value it can't. Like X can't equal 3 in this. This one, the blue one, the domain is everything, this is how you'd rate it. And the range is everything. Right, for the blue one. But in the green one, we have a non-permissible value that we have to take into consideration. Okay. Oh, loving it, loving it. Circle these 2 questions.
What questions?
6 and 7.